Alright, here's the NECO 2023 instructional material, and from your instructional material you will see the first one here. We'll start with the preparation and the calculation of the concentration of the stock solution of sulfuric acid. It says 150 cm cube of H2SO4 solution in a cork flask labeled AN, and this should all be the same, containing 2.20 cm cube of concentrated sulfuric acid per dm cube. Okay, so we'll measure at 2.20 cm cube of the acid and dilute to 1 dm cube, which is 1000 cm cube. Then if we do that, what is the concentration of the solution? It's a very simple thing. You use your dilution formula, which is C1 V1 equal to C2 V2. All right, your C1 is your initial concentration, which is the initial concentration of your stock solution of your sulfuric acid. All right, it usually comes in 18 mole, so it's 18. Then your V1 is the initial volume, which is 2.20 cm cube, 2.20 cm cube. Then your C2 is the final concentration after dilution, alright, which is unknown, is what we're looking for. And your V2 is your final volume said per dm cube. Okay, take note, 1 dm cube, that's it, that's the meaning of it. And 1 dm cube, you know, it is equivalent to 1000 cm cube. So our V2 is 1000 cm cube. Alright, so when you do this, you substitute into the formula, which is C1 V1 equal to C2 V2. Your C1 is 18 mole times your V1, which is 2.20 cm cube, and your C2 is what we're looking for, times your V2, which is 1000 cm cube. Alright, so now we have 18 times 2.20, 18 times 2.20, we have it as 39.6 equal to C2 times 1000. Alright, so we'll divide both sides by 1000 to get C2. So if that's the case, we'll have it like this: 39.6 divided by 1000, 39.6 divided by 1000. Alright, so our concentration becomes 0.0396 mole per dm cube. Okay, so this is the concentration of your AN of the acid. Now let's go over to the next one, which is B. It says B should all contain 150 cm cube of sodium triazocarbonate 4, and this should all be the same, containing 3.6 grams of sodium carbonate per dm cube. So we'll dissolve 3.6 grams of sodium carbonate and then we'll dilute to 1000 cm cube. So if we do that, what becomes the concentration of the solution is a very simple thing to calculate. That means we're having 3.6 grams of sodium carbonate per dm cube, which is in 1000 cm cube. Alright, what becomes the concentration if we dissolve 3.6 grams of sodium carbonate in 1000 cm cube? So you can use this formula to get the concentration of the solution, which is concentration is equals to the amount is in mole over volume of solution, volume in dm cube. Alright, so let's go. We are looking for the concentration by dissolving 3.6 grams of sodium carbonate in 1000 cm cube. So um, concentration is equal to amount. And now what's amount? Amount in mole, from the formula for amount which is in mole is equal to mass over molar mass. So let's calculate this one first. Let's calculate the amount first so that we can just substitute into the formula. Now, mole, the um, mass is 3.6 grams, and the molar mass of sodium carbonate, that is Na2CO3. Molar mass, if you calculate the molar mass, you should be having 106 grams per mole. All right, so our molar mass is 106 grams per mole. Is substitute into the formula, which is mole equal to the mass, which is 3.6 grams over 106 grams per mole. Alright, you do that to calculate the mole. That is um 3.6 divided by 106. You have it at 0.03396. Alright, which is 0.03396 mole. So you substitute into the amount here, which is 0.03396 mole over the volume. Take note, it 1000 cm cube. Okay, that is per dm cube. All right, our volume here is in dm cube. You know 1000 cm cube is equivalent to 1 dm cube. Take note of that. 1000 cm cube is equivalent to 1 dm cube. All right, so per dm cube, which is 1 dm cube, we are using dm cube because the unit here is in dm cube. All right, so when you divide this, the concentration becomes 0.03396 mole per dm cube of Bn. So this is the concentration of your Bn, which is your sodium triazocarbonate 4. I believe it is very clear enough. So let's go further to the preparation of the solution, the practical aspect of it.
So measure the Bn now, which is your sodium triazocarbonate 4. We'll measure out 3.6 grams of sodium triazocarbonate 4. And here we go. And you go further to dissolve in little quantity of water. You stir to ensure all particles dissolve properly in it. And after stirring, here is our 1000 ml volumetric flask. You add it to it. You can raise the little portion out from it by adding it to it also, and then carefully add more water until you get to the 1000 mark, which is the calibration 1000 calibration mark there. Carefully add and ensure you take your readings at the meniscus. So here is how you prepare your AN. This is sulfuric acid. You measure at 2.20 cm cube of sulfuric acid using this measuring cylinder here. Ensure you're very careful. This is concentrated. That's it. Alright, and then first you add little quantity of water to your 1 dm cube volumetric flask before you add your acid. Ensure you add acid to water, not water to acid. Now you can add your acid to it, and then you dilute. You rinse a little from it first. You rinse it into it, and then you dilute to the 1 dm cube mark there. Alright, so here we go with our AN.
Alright, let's just go further to calculate the theoretical range of the endpoint. Here's the equation for the reaction. This sulfuric acid H2SO4 reacting with sodium carbonate. When an acid reacts with the carbonate, it gives you the salt of it, water, and carbon dioxide gas. So from the concentration of the acid, which is our AN. We have the concentration to be 0.0396 mole per dm cube, and the concentration of our base, which is Bn, which is this one, is 0.03396 mole per dm cube. All right, so long as we have the concentration of the acid and the base, we can go further to just calculate the theoretical endpoint. So if that's the case, you can use this formula, which is our CAVA over CBVB equal to NA over NB. Alright, where your Ca is the concentration of the acid to be 0.0396 mole per dm cube, and your Va is the volume of the acid, which is what we are looking for in this calculation, the average volume of acid used, which is our endpoint. Then our CB is the concentration of the base, which we have it at 0.03396 mole per dm cube, and your VB is the volume of the base, which we, depending on what you want to use, but I prefer going with the 25 cm cube, which is the size of your pipette. All right, so we'll have it to be 25 cm cube, and then our Na, number of moles of acid, is 1 from the equation, and Nb, also number of moles of the base, is also 1. So our Na is 1 and Nb is also 1. So when you substitute this into the equation and look for Va, it becomes Ca is 0.0396 mole per dm cube, times your Va. Your Va is what we're looking for, over Vb, which is Cb 0.03396 mole per dm cube, times 25 cm cube, equal to 1 all over 1. All right, these units will cancel each other. Then you cross multiply. If you cross multiply, you have 0.0396 times Va times 1 gives you the same thing. And this one, you also have 0.03396 times 25 times 1 gives you the same thing. So let's go further to calculate this. So so we have 0.03396 times 25. So we have 0.849. So we divide both sides by 0.0396 to get our Va, 0.0396. So if you do that, Va becomes this. So 0.849 divided 0.0396. So we are having 21 point approximately 44 cm cube, 21.44 cm cube, right? So your average volume of acid used, which is your titrate value, should fall within this range. All right, so this is just like a guide where you want to carry out your practical to your final answer. So go over to the practical aspect of it so that you see how the practical is being carried out.
Alright, here's the practical aspect. You measure out 25 cm cube of your BN into your conical flask. 25 cm cube of BN, that's one. Then add 2 to 3 drops of methyl orange. Here is our bullet. You fill to the 0 mark with your AN, which is your acid. and I just take readings from the meniscus. And after that, you go further to titrate to get your endpoint. Alright, keep swirling till you get to the endpoint. Alright, we're there now, which is orange color. You can compare with the other conical flags to see the difference. And then the endpoint of this reaction is 21 cm cube, which you can see clearly from here.